This chapter covers quite a bit of ground when it comes to functions. So let's zero in on a particular aspect of this chapter, and that's transformations. So a transformation, just like the name implies, is looking at how we can take sort of a base graph and then move it around. We can either squeeze it or we can move it left or right, up or down. Um, and so that's what we're going to look at in particular. So let's do that just with an example that hopefully will be kind of helpful. Let's take a cubic function, and then let's make it have a little more of a a little more of a whoop, a little dip there. Okay, so this is going to be our basic function right here. So first off, let's look at horizontal scaling. So horizontal scaling is if you add a multiple um, sort of within the function. So like if we were doing it with our x cubed minus 3x, this would be, let's do a 2. So it pretty much would entail just adding a parentheses 2x everywhere that you would see an x. And there we go, voila. So you can see with this horizontal scaling, the blue is our original function right here. And you can see that it goes just as high and just as low as that, but it's squeezed in. It's taken from the blue and it's pushed in the middle. And this is kind of as opposed to, let's say you wanted to do maybe 0.5x. So it works with decimals or fractions also. So 3 times 0.5x. There we go. And this blue one you can see. So you see here's our original on the blue. So we added a constant of 2 within there, and it looks like it took my parentheses out of there, but it's kind of just place them there in your mind so you get the idea. So here we add 0.5, and it draws it out. It sort of pulls it apart. So that's going to be horizontal scaling right there. All right, so now let's take a look at another one. Let's take a look if we would just want to move it horizontally. So this is going to be a horizontal shift. So let's see, let's move it 3, I guess. So in this one, you have your function, and then within the function itself, you're just going to do a minus or a plus. So you'll notice that it's a minus is going to shift it to the right, and a plus is going to shift it to the left. So minus 3 times x minus 3, and there you go. That's kind of a little confusing to look at, but this is our first function right here, and then this is our second function right here. Oops, right there. So you see, it just took it almost like it was like a cookie cutter. It took it and just boom, just moved it 3 to the right. As opposed to if you wanted to go the other way, you just you could add a plus in there, and voila, then it's going to move it over to the other side. All right, so that's your horizontal shift. Again, you can think of it as sort of, if you're horizontal scaling, you're squeezing or pulling it apart. If you're shifting it, you're just moving it to the left or to the right. So, all right, so that's horizontal. Let's take a look at vertical. So with vertical, y equals, it's going to come just on the outside. So our function is going to stay the same. We're pretty much multiplying everything by a constant value. So there we go. And as you can see with this vertical scaling, it's going to pull it up or down. So it's going to cross these lines at the same spot. It's just going to go up further or down. So with horizontal, where it's sort of squeezing and pulling, this one is doing it the same kind of an idea, but it's going to pull it up or down more. So there you go. So that, and then of course the same thing. If like we did, you could do maybe like 0.5 x cubed minus 3x. There we go, and you see it's not quite. This is our original function, and it's a little this peak here and this valley here not quite as pronounced. So again, that's just what scaling does, right? You can either squeeze or pull it up in the vertical direction. All right, and then the last one that we'll look at is we're going to look at delete. All right, we're going to look at a vertical shift, and that's when if it just comes at the very end. So it's going to be your function f of x and then plus or minus some value at the very end. So our function itself stays the same. It's 3x. All right, and then let's just we'll do maybe plus 3. All right, so there we go. You can see that that's going to shift it vertically 3. So where everything, like for example, for here was -2, and then it's just going to add 3 to everything. So that's going to be up there at +1. So it's the same shape. It's just the entire thing is like a mirror image of it. Or maybe not a mirror image of it, but like someone just took it and moved it up the graph. And so that's vertical shift. So those are the 4 big ones that it goes over. It's kind of neat. It's really it's helpful to be able to know how a graph is going to look based off of kind of the basic structure and then how it might be transformed. So this is something that can come in handy if you're just looking for a quick sketch or to understand kind of the behavior of a particular graph or function. So yep. So there you go. Transformations. There's a lot more in the chapter. So worth reading it over. But this is kind of the basics of how these things transform.